Hi everyone, I am John Cedric C. Jimenez from BSAEE 2-7, and for today we're going to talk about accident causation models. What is aviation safety and accident causation models? We know that in our world, in our society, all of us have experiences of accidents and incidents all throughout our life. We know for a fact that accidents cannot not happen. Okay? Hindi pwedeng mawalan ng accident sa isang bagay o sa isang scenario. Okay? Pwede lang tong ma-prevent. Ano nga ba una ang accident kasi? So, ang accident kasi, it is a complex coincidence of activities or phenomena in a single time and space. These accidents can either cause bodily harm or it can cause property damage inside the system. So, pwedeng maging as simple as a cut or a bruise sa isang personnel. Pwede rin itong mag-result sa isang casualty or sa isang fatality. Ang incident naman, basically, sinasabi dito na ang incident is a minimal or mas minimal siya kesa sa isang accident. Pero, alam naman natin na sa isang company or sa isang operation system, hindi natin ma-prevent na magkaroon ng accident. Although ma-prevent natin sila from happening, pero hindi sila mawawala totally. Pwede lang natin silang pigilan, pwede lang natin silang bawasan. Okay? So, ang next natin is, ano nga ba ang accident causation models? Ang accident causation model, basically, ito yung mga dinevelop ng iba't ibang tao tulad nila James Reason, nila Holnagel at ni Heinrich noong 1931. Ito yung mga systematic methods na sinasabi kung bakit nga ba nangyari yung isang accident, kung paano nangyari at paano natin mapipigilan ito sa susunod. Okay? So, meron tayong tatlong types ng accident causational models. Okay? So, the first one will be simple linear. From the word itself, simple linear. Ibig sabihin, diretso siya. Direct. Okay? Ito yung sinasabi na ang isang accident daw, parang sequence siya of events na parang dominoes. Okay? Ang isang example dito is yung domino model ni Heinrich noong 1931. So, ang sinasabi dito, alam natin pag nag-stack tayo ng dominoes, na tabi-tabi sila, at saka pag tinulak mo yung isa, alam natin na parang magkakaroon ng sequence of events na babagsak sila. Okay? Dito sa domino model na to, sinasabi dito na if ever man mayroong isang domino na mag-step out or magkaroon ng gap between those two dominoes at ma-stop yung domino, doon na magkakaroon ng prevention sa accident na mangyayari. Okay? So the next one is the complex linear causation models. So, ito, sinasabi dito na yung isang accident daw ay mayroong iba't ibang unsafe conditions and factors na nagkakaroon na pwedeng makasakit or pwedeng makaapekto sa isang individual na nagtatrabaho doon sa isang system na yan. Ang isang example na ito is yung Reason's Swiss cheese model, which I'll be explaining later on. The third one, and the last type of accident causation models is the complex nonlinear. So, a complex nonlinear, from the word itself, makita natin na parang ito yung cause ng ito yung accident na tipong gawa siya ng multiple interacting factors. Iba't iba siya. Okay? So, dito kasi, parang masasabi din natin na parang non-direct siya. Okay? So, parang iba-iba yung patungo ng actions ng iba't ibang factors. Ang isang example nito is yung systematic theoretic accident model and process stop, or yung tinatawag natin stop. So, pag sinabi natin active failure versus latent conditions, masasabi natin na ang isang active failure kasi, it is an error or violation with an immediate adverse effect, usually done by an frontline operator. So, from the word itself, active failure, ibig sabihin, ang isang example nito, if as pilots, halimbawa piloto, nasa ere ka, tapos magla-landing ka na, kailangan mong mag-landing ng safe, di ba? So, sa mga piloto, mga pilots kasi, meron tayong mga iba't ibang checklist. Halimbawa, landing checklist, startup checklist. Pag hindi natin nasunod, halimbawa, yung isang piloto na to, magla-landing na siya, hindi niya nasunod yung isang item doon sa checklist na, at nagkaroon ng accident doon sa aeroplano niya. Ibig sabihin, nagkaroon siya ng hard landing. Okay? Ibig sabihin nun, ito ay isang active failure kasi naka-apekto agad to directly doon sa situation niya, doon sa safety ng system niya. However, yung latent conditions naman, ito yung resulta ng mga decisions, ng mga designs, or mga actions na ginawa bago pa magkaroon ng accident. Or masasabi natin na late siya. Okay? Yung effects netong latent failures or latent conditions na to is medyo malilate siya kesa sa active failure. Okay? It can be a cause of poor design sa isang system or sa isang equipment, or it can be inadequate supervision and resources. It can be bad or improper management of an authoritative staff. Basically, it has an indirect impact doon sa safety ng isang system. So, the next one is reasons Swiss cheese model. So, ito na nga. Yung reasons Swiss cheese model, ito yung sinasabi ni James Reason na nire-represent yung isang safety system ng isang operation. Bawat cheese dito sa nakikita nyo ay nagre-represent ng isang safety system or barrier kung tawagin. Bawat butas sa safety system na ito ay nagre-represent ng deficiency or ng weakness within the system. So in an ideal world kasi, yung cheese kasi dapat walang butas. Okay? In an ideal world, ibig sabihin ng walang butas is walang deficiency, walang weaknesses yung isang system. Pero in our reality, meron tayong mga weaknesses talaga, diba? So it can be either engineering controls, administrative, behavioral, and sa mitigating barriers. Okay? So, etong Swiss cheese model na to, sinasabi lang, mas maganda kung ma-explain natin in an example. Halimbawa, sa isang factory or sa isang manufacturing industry, meron kang isang engineer na gumawa ng bagay para sa isang product. What if nag-design ka ng medyo flawed na system, na design, na product? Okay. Ibig sabihin, yung trajectory of accident na yon, yung pulang linya na yun, pumasok sa isang butas, pumasok sa isang deficiency or weakness doon sa part mo, sa system mo. Okay, nakapasok na siya doon. Next, mapupunta yung design mo doon sa administrative controls. Kaso hindi rin nila na-check kung maayos ba yung system mo. Na-check nila pero may mga nakaligtaan silang process or may mga nakaligtaan silang parts ng design mo. Therefore, pumasok ulit yung trajectory of accident doon sa butas naman ng administrative control. Pero halimbawa doon naman sa manufacturing or sa behavioral controls naman, pagdating doon, na-check nila, na-double check nila na ay, may sira pala to, ay, may flaw pala dito sa design mo. So, therefore, dito magkakaroon na ng deflection. Madedeflect na yung trajectory of accident. Therefore, mawawala ng accident. Pero let's say, in the worst case scenario, lahat ng barriers na to nalampasan ng trajectory. Ito na yung point na magkakaroon ng accident. Okay? So, makikita natin dito sa picture is meron tayong engineering controls, administrative, at behavioral controls. Itong tatlo na to, engineering, administrative, and behavioral, ito yung tinatawag na preventive actions. Okay? So, sila yung, kumbaga, double, triple check ng isang bagay bago makapasok sa manufacturing. Okay? So, kung makikita natin, pagka pass through doon sa tatlong barriers na mayroong nagkaroon ng incident. So, yung incident yung sinasabi ko nga kanina na parang minimal injury or minimal damage lang siya doon sa isang system. Okay? After nun, nung minimal damage na yun, syempre, magkakaroon yung mitigating barriers na tinatawag. Yung mitigating barriers na yan, ibig sabihin, pinaprevent niya na magkaroon pa ng accident or magkaroon pa ng consequences. Okay? So, yun yung Swiss cheese model. These layers are layers of protections. So, ano nga bang pwede natin gawin para maiwasan yung accidents, di ba? Pwede tayong halimbawa sa isang chemical factory or laboratory, pwede tayong magsuot ng personal protective equipment or PPE, pwede tayong sumunod sa lab procedures, pwede tayong magkaroon ng emergency response plan, or pwede tayong magkaroon overall ng safer at much more efficient design. So, yun yung Swiss cheese model. So, the next one will be organizational accident. Organizational accidents. So, these organizational accidents basically contains organizational processes that when not met, this can lead to accidents. We can see that there are dual pathways or two pathways that can lead to an accident inside a system. Okay? So the first pathway we're going to discuss is the latent conditions. The latent conditions, this can be deficiencies in design of an equipment or a training in personnel. These latent conditions are further classified into two clusters. First one is the safety risk. So the safety risk, these are latent conditions that are freely roaming, that can be triggered and activated by personnel. The second one is the normalization of deviance. The normalization of deviance is, these are because of the extreme flaws of the system. The personnel involved in the operation is forced to make a shortcut, therefore violating rules, and therefore is prone to accidents. So the second pathway is the workplace condition pathway. The workplace condition, we all know that this directly influences the personnel or the person that is working on an operation. This can include lighting, ergonomics, heating, cooling, food, anything that concerns an individual and his or her workspace. We can say that low quality workspace is equal to more prone to active failures. So these active failures can include errors or violations. An error is basically a active failure that is done without intent. And a violation is active failure or a failure that is done with intent. So, ano nga ba yung practical drift na tinatawag? So, yung practical drift kasi na gawa ni Scott A. Snook, ito yung sinasabi ng theory na basically, however well a system is a system designed, at some point it will fail, okay? At some point it will drift from the original baseline performance. So, makikita natin dito sa picture na to, yung baseline performance at saka yung operational performance. Kapag sinasabi natin dito na halimbawa yung isang system or safety system, kapag in-implement na natin to at operational na siya, yung baseline performance na tinatawag natin, yung parang pinredict natin or yung gusto nating mangyari, magkakaroon siya ng practical drift, okay, sa operational performance. Bakit nga ba magkakaroon ng practical drift? Pwede itong dala ng technological failures, ng procedural deficiency, at saka pwede din itong maging dahil sa introduction of changes to a system. Okay? So, halimbawa, sa isang system, maayos na yung lakad, maayos na yung pamamalakad mo kasi na-implement na. So, nagkaroon ng technological failure. Syempre, di ba, magkakaroon na ng practical drift doon sa operational or doon sa projected na performance mo. Okay? Ganun lang yan, basically. So, paano nga ba natin ma-prevent or mababawasan itong practical drift na itong sinasabi? Ma-prevent natin to at mababawasan natin kung i-check natin palagi yung mga safety systems from time to time at i-recertify natin itong mga safety systems na to thoroughly. Ito ay ginagawa upang ma-predict natin yung mga hazards at yung mga risks na pwedeng mangyari doon sa system natin. Pag nalaman na natin itong mga risk and hazards na to, pwede na nating ibahin or improve yung system. Again, ako po si John Cedric C. Jimenez from BSAE 2-7, and thank you for listening.